Welcome to our today's discussion. Welcome to this discussion. Today we are looking at covalent bonding. Previously we talked about an ionic bonding, where we said that an ionic bond is a bond formed when there is complete transfer of valence electrons, and that ionic bond exists between metals and nonmetals. Today our discussion is on covalent bonding. We said that a covalent bond is a bond formed when we have sharing of valence electrons, and we said valence electrons are electrons in the outermost energy level of an element. Another thing we said is that a covalent bond exists between nonmetals. Let us look at some few examples to demonstrate on how an ionic bond is formed. And we are going to look at our first example on the formation of hydrogen molecule. Hydrogen molecule is formed when we combine two hydrogen atoms together to form hydrogen gas, which is a molecule. In this case, we know that hydrogen is found in atomic number 1 with only 1 electron, and for it to have a duplet state of 2, it requires to gain 1 electron to make them 2. Since we have 2 atoms, none of these 2 atoms is going to lose an electron to the other, and therefore the 2 are going to end up sharing their electrons. The first hydrogen atom has 1 electron. We can sketch this by showing its structure. It has 1 electron here, and the other hydrogen also has 1. We can represent it this way. So for them to acquire stability of 2, they need to share their electrons, and since there is sharing, we are going to have their structures drawn as 2 intersecting circles, where this one has 1 and the other one brings its 1 electron for them to form hydrogen molecule where the atoms are covalently bonded. This bond can also be represented as H with a single bond, meaning they have formed a single covalent bond since they shared 1 of their valence electrons. Number 2, we can look at another example by looking at how a water molecule is formed. Formation of water molecule, and a water molecule contains 2 hydrogen atoms and 1 oxygen atom. When drawing a structure like this, oxygen is going to covalently bond with 2 hydrogen atoms, and this is how we are going to present their structures. This is oxygen bonding with 1 hydrogen on this side and the other one on this other side. Remember, hydrogen has only 1 electron. Oxygen in atomic number 8 will have 2 6. It is going to use the 6 valence electrons in bond formation. Hydrogen has its 1 electron on this other side. This hydrogen will donate its electron here. Oxygen will also donate 1 so that this hydrogen is satisfied. On this other hand, hydrogen has its own 1. Then oxygen will donate another 1 here so that this other hydrogen is satisfied. Oxygen has 2 this side. It also has 2 this side. And we need them to be 8, and therefore the remaining 4, after donating 1 here and another 1 here, you place them here so that oxygen is also satisfied, and that is how a water molecule is going to be formed, or how covalent bonds form. This can also be written as hydrogen bonding with oxygen by getting one electron, and also this oxygen bonding with another hydrogen, leading to the formation of a water molecule where the atoms are held together by covalent bonds. The last example we are going to use, let us see how a chlorine molecule is formed. Formation of chlorine molecule. Chlorine molecule is made up of two chloride atoms, and in this case we know that chlorine is found in atomic number 17 with an electron arrangement of 287. The other chlorine also has the same electron arrangement. We are going to focus on the valence electrons, or electrons in the outermost energy level. So we are going to present our diagrams like this. Since there is sharing, they have to crisscross like this. This is one chloride atom and this is the other one. Remember, this one has 7 electrons. Those are the 4. We have 6 and the 7th one is here. This other chlorine has 7. We have 1, 2, 3. That is 4 already. These are the 6. And the 7th one is going to be placed here so that they share the 1 electron, so that both of them will be satisfied with 8. And if you count, this one is supposed to have 8 for it to be stable. We have 2 here plus the other 6. This one has 2 plus the other 6, and therefore the 2 are now satisfied. And this can also be written as ClCl, meaning they have shared 1 electron in each case for us to have a single covalent bond. Thank you for watching and welcome to this channel. And in case you are watching this channel for the first time, kindly take 1 second and click the subscribe button so that anytime we do a video like this, you'll automatically be given a notification.